Welcome you all to module 4 class 4. So today we will discuss about the concept of recursion. This is another concept of the functions, and this is the last concept of this module. We will see what is the concept of recursion with the help of some example programs. Now, recursive functions. So recursive functions are those functions that call themselves during their execution until certain conditions are not satisfied, or recursive functions are those functions which call itself. So here we make one call to the recursive function, then the function calls itself and the execution takes place until the certain condition is met. Once the condition is met, the recursive call stops. We will see an example program, that is factorial of a number, using the concept of recursive function. Now here, so the factorial of a number using recursion. So now the example is shown here. Now n factorial, the formula is n into n minus 1 into n minus 2, so on up to 1. Now for example, here we given 5 factorial is represented as 5 into 4 into 3 into 2 into 1. Now factorial of 5, that is we have defined, we have declared a function here by the name factorial. So now for example, I want to find 5 factorial, then the call is factorial of 5. That is how I am calling the function now. So 5 into factorial of 4, then 5 into 4 into factorial of 3. So 5 into 4 into 3 into factorial of 2. Similarly, factorial of 0 is executed, that is 1. That is a condition when the recursive call to the function factorial stops. So now we will see the program here. So hash include stdio.h, that is the standard input output header file. Next, I have declared the function here. The name of the function is factorial. It will compute the factorial of the given number and send the result back to the calling function. In this case, it is the main function. So that's why I mentioned the return type as integer. It is going to return an integer value. Factorial is the name of the function and it accepts a number from the main function. So that's why I mentioned int n as the argument. It accepts one argument and then returns the result back to the calling function. So int factorial int n. Now void main, because main does not return anything, so void main I have mentioned. Now int n comma fact, since the factorial function accepts an argument and returns the result back to the function, I need a variable here to make a call to the factorial function. So that's why I have declared the variable fact, which is of integer type. Then I have to accept the number from the user, so I need a variable to store that. So I have declared n, the variable n, for that purpose, which is again integer type. Next, printf enter a number %d comma ampersand n, that is I am going to store whatever the input given by the user in the variable n. Next, I am calling the function factorial. So fact equal to factorial of n. Now once factorial of n function is called, then control will go to the factorial function. Now what happens in the factorial function? That is the recursive function factorial. Now that is shown here in the example here. So I have taken 5 as the input. So factorial of 5, that is the function is called. So now once the factorial of 5 is passed to the function, control will go to the function factorial. Then you can see here, first the condition what is checked is if n is equal to 0. So first time, now n is 5, so 5 is equal to 0 is tested. Since 5 is not equal to 0, so the if condition becomes false, so else condition is executed. Once it comes to else part, return n into factorial of n minus 1 is executed. So now n into factorial of n minus 1 becomes 5 into factorial of n minus 1, that is 5 minus the 1, that is 4. So n into factorial of 4. So it becomes 5 into factorial of 4. Now factorial of 4 means again the factorial function is called. So again control will come back to int factorial int n. Now the value of n is 4 now. So again if n is equal to 0, again the condition n is equal to 0 is tested. Now again 4 is not equal to 0, so else part is executed. So since else part is executed now, so the return part is executed, that is n into factorial of n minus 1. n into factorial of n minus 1, now it becomes 4 into factorial of 3. So 5 into 4 into factorial of 3. Once again the factorial function is called. Now the input n is 3. So again control will come back to int factorial of int n. Now value of n is 3 now. So again if n is equal to 0, that is if 3 is equal to 0, condition is checked. Since 3 is not equal to 0, again else part is executed. So return n into factorial of n minus 1. So n into factorial of n minus 1 becomes now 3 into factorial of n minus 1, that is 3 minus 1, that is 2. So 5 into 4 into 3 into factorial of 2. So again factorial of 2 means again the factorial function is called. So control will again come back to int factorial of int n. Now the value of n is 2. So n is equal to 0, condition is checked first. Since 2 is not equal to 0, again else part will be executed. Return n into factorial of n minus 1. So now 2 into factorial of 2 minus the 1. So 2 into factorial of 2 minus the 1 is 2 into factorial of 1. So again the factorial of 1, again factorial function is called. So again control will come back to int factorial of int n. Now you can see here 5 into 4 into 3 into 2 into factorial of 1. Now factorial of 1 is executed. Factorial of 1, that is n is 1 now. So if n is equal to 0, condition is again checked. Now 1 is equal to 0, so condition is false. So again else part will be executed. So n into factorial of n minus the 1, that is 1 into factorial of n minus the 1. 1 into factorial of n minus the 1 is 1 minus the 1, 0. So 1 into factorial of 0. So 5 into 4 into 3 into 2 into 1 into factorial of 0. So now factorial of 0 means again factorial function is called. Now n value is 0. So if n is equal to 0, condition is checked. So 0 is equal to 0, condition is true. So return 1 and the function stops here. So 5 into 4 into 3 into 2 into 1 into 1, that is 120 is total is 120, that is returned back to the calling function and the result is stored in fact. Okay. Now we'll see the tracing of the program. Now here for example I have taken n as 5. So user inputs n value as 5, so that will be stored in variable n. Then the statement fact equal to factorial of n is executed. So factorial of n here is now factorial of 5. So once the function call is executed, the control will go to the function factorial. Now in factorial function we have given int factorial int n. So whatever value we are passing from the main function will be copied to the variable n declared in the factorial function. Now you can make a note of the arrow here. Arrow pointing downwards shows the order in which the function call is made, and the arrow pointing upward shows the order in which the return is executed. So now fact equal to factorial of 5. When this statement is executed, the first function call is made. So now the control will directly go to the factorial function. Now first the condition if n is equal to 0 is checked. So now since n is 5 now, so 5 is equal to 0 is checked, it is false, so the else part will be executed. Now in the else part, return 5 into factorial of 4, that is return n into factorial of n minus 1. So n is 5 here, so 5 into factorial of n minus 1 is 4, so factorial of 4. Now first recursive call is made here. Now again I am calling the factorial function. So again now the control will go to the factorial function. Now n value is 4 now. So again if 4 is equal to 0, condition is checked. Since condition is false, so again else part will be executed. Now return 4 into factorial of 3, that is n into factorial of n minus the 1. 4 into factorial of 3 is executed. Now again another recursive call to factorial function. Now n is 3 now. So control will go to the factorial function. So again now n is equal to 0. N is 3 now. So 3 is equal to 0. Condition is checked. So false again. So else part is executed. So now return 3 into factorial of 2, that is n into factorial of n minus 1 is executed. So now again call is made, recursive call is made to factorial function. Now the value of n is 2 now. So again control will go to the factorial function. So if n is equal to 0, now the n value is 2, so 2 is equal to 0. Again condition is false, so else part is executed, that is return 2 into factorial of 1 is executed. So again there is another recursive call to factorial function. Now factorial of 1, that is n is now 1, so control goes to the factorial function again. So now 1 is equal to 0, again the condition is false, so else part is executed. So return n into factorial of n minus 1, that is 1 into factorial of 0 is executed. So again there is a recursive call to factorial function. Now n value is 0, so the control will go to the factorial function. So first condition, that is n is equal to 0 is tested now. Now n value is 0, so 0 is equal to 0, condition is true, so return 1 is executed. So once n becomes 0, return 1 is executed, the recursive call stops there. So now return 1 is executed, so the function call factorial 0 returns the value 1 back to the calling function. So you can see the arrow pointing upwards. Now 1 is returned, so the return statement now becomes 1 into the value returned by factorial of 0 is 1, so 1 into 1, so 1 is returned back to the previous call. Now 2 into 1, that is 2, so return statement now executed, so 2 into 1, 2 is returned back to the previous call. Now 3 into 2, that is the factorial 2 has returned the value as 2, so 3 into 2, that is 6, will be returned to the previous call. So now 4 into 6, that is 24, 24 is returned back to the previous call. Now 5 into 24, that is 120, is returned to the first call made by the main function. So return statement now executed will have the value as 120, that will be returned to the main function. So 120 will be copied to fact and the output is displayed in the main function. So you can clearly see here the order in which the function call takes place, then finally the return execution sequence also you can see the order. So that like this the recursive call takes place and the return takes place in the order is shown here. So finally 120 is returned back to the calling function. So we have just called the function factorial once in the main program, and the function calls itself for until the condition, that is n is equal to 0 is true. Till that the recursive call executes. Once that condition is true, the return takes place, and finally the result, that is 120, the factorial of 5, is returned back to the calling function. So next example is to generate the Fibonacci series up to n term. So the general form of Fibonacci series is the nth term xn can be obtained by adding the previous two terms, x of xn minus 1 plus xn minus 2. So starting, the Fibonacci series starts with 0 and 1 as the first two Fibonacci numbers. Third Fibonacci series number can be obtained by adding the first two, that is 0 plus 1, so 1. Similarly, the process continues 0 1 1 2 3 like that. We have already seen the program to generate the Fibonacci series. Now we'll see how we can generate the Fibonacci series by making use of the concept of recursion. So again, int Fibonacci of int n. Now this is the function I have declared here. So the name of the function is Fibonacci, and it accepts the nth number, or it accepts the nth term from the calling function, that is the main function. So I have taken it as int n. Then it returns the result back to the main function, that is the Fibonacci series which is generated will be displayed in the main function itself. That is why it is returning the generated Fibonacci series number back to the main function. So return type I have mentioned it as int. Now in the main function, int n, I and x, three variables I have declared over here. So n is to accept the nth number of the Fibonacci series, I is to generate each individual number of the series. I need to make use of a loop and generate each number of the series, so I make use of I for that purpose. Then x, variable x I have used here to make a call to the Fibonacci function. Since the Fibonacci function takes an input argument, also returns the value back to the calling function, so I need a variable to make a call. So I am making use of x to make a call, and which will also store the Fibonacci series number generated by the function Fibonacci. Now printf enter n. Now for example here I'll take n as 3. For example, user entered the value for n as 3, so n will be 3 will be stored in n. Next, printf Fibonacci series is. Now using the for loop, I'll make a call to the Fibonacci function and generate each Fibonacci series number. So for I equal to 0, I is less than n, I plus plus. So now you can see here in the main function, now n is 3, and since n is 3, so I can run up to 0 1 2. So initially now I is 0, so 0 is less than 3, condition is true, so control will come inside the for loop. Now x equal to Fibonacci of I. So now I is 0, so the function call will be Fibonacci of 0. So I am making a call to the function Fibonacci, and the input argument what I am passing is I, which holds the value 0. So now control will go to the Fibonacci function. So int Fibonacci of int n. Now whatever value is there in I will be copied to n. So now here in the Fibonacci function, n is now 0. So first the condition is checked, if n is equal to 0. So 0 is equal to 0, condition is true, so return 0 is executed. So return 0 is executed. So the first call, that is Fibonacci of 0, what we have made a call, so it returned 0, so 0 will be copied to x, and printf %d slash n comma x. So the first Fibonacci series number is displayed, so 0 is displayed. Next, I is incremented by 1, I becomes 1 now. So again I is less than n, that is 1 is less than 3, condition is true, so control will again come inside the for loop. Now x equal to Fibonacci of I, so I value is 1, so Fibonacci of 1, I am calling the function Fibonacci. Now again control will go to the Fibonacci function. So now n is equal to 1 now, so whatever is there in I will be copied to n, so I is 1, so that will be copied to n. Now the condition, if n is equal to 0 is checked, it is false, since n is now 1, so 1 is equal to 0 is false, so else if part will be executed. Now n is equal to 1, so now 1 is equal to 1, condition is true, so return 1 is executed. So the control will come back to the calling function. So Fibonacci of 1 has returned the value 1, that will be stored in X, and then printf statement is executed. So whatever is there in X will be displayed. So 1 is displayed now. Next again I is incremented by 1. Now I becomes 2. So condition I is less than n is checked. So 2 is less than 3 condition is true. So control will come inside the for loop. Now X equal to Fibonacci of I. So that is now Fibonacci of 2. The function call is executed. The control will come to the Fibonacci function. Now Fibonacci of int n. So here now I value is 2 will be copied to n. Now first the condition is checked. If n is equal to 0. Now n is 2 now, so 2 is equal to 0, condition is false. So else if part will be executed. So else if n is equal to 0. So now n is 2, so 2 is equal to 0, 2 is equal to 1, condition is false. So else part will be executed. Now since the else part is executed, now here return Fibonacci of n minus 1 plus Fibonacci of n minus 2 is executed. Now here I am making the recursive call to the Fibonacci function. So Fibonacci of n minus 1 is now 2 minus 1, that is 1, plus Fibonacci of n minus 2 is now 2 minus 2, that is 0. So Fibonacci of 0, Fibonacci of 1 plus Fibonacci of 2. So the return statement is executed. First there is a recursive call now Fibonacci of 1. So once Fibonacci of 1 is called, again control will go back to the Fibonacci function. So int Fibonacci of int n. So now the value of n is 1. So Fibonacci of 1 is executed now. So value of n is 1. So if n is equal to 0, condition is checked now. Since n is equal to 0, that is 1 is equal to 0, condition is false. So control will go to else if part. Now else if n is equal to 1. So 1 is equal to 1, condition is true. So return 1 is executed. Next Fibonacci of n minus 2 is executed. So Fibonacci of n minus 2 means Fibonacci of 0 is executed. So again control will go back to the Fibonacci function. So Fibonacci of int n. Now n is 0. Since Fibonacci of 0 is executed, so n becomes 0. So if n is equal to 0, that is 0 is equal to 0, so condition is true. So return 0 is executed. So first call, that is recursive call, Fibonacci 1 returns 1, Fibonacci of 0 returns 0. So both are added. So return 1 plus 0, that is 1. That will be, result will be returned back to the main function. So now the call x equal to Fibonacci of 2 returns x equal to 1. So now 1 is displayed in the main function. Then I is incremented by 1. Now I becomes 3. So n is also 3. So 3 is less than 3, condition is false. So control will come outside the for loop and the program terminates. So when we make a call x equal to Fibonacci of 2, then the last return statement is executed. So there is 2 recursive calls are made within the statement, that is Fibonacci of 1 plus Fibonacci of 2. So once Fibonacci of 1 call is made, the return 1 is executed, so that will be sent back. Then Fibonacci of 2 is executed, so return 0 is sent back. So that will be added here in the return statement, and that result will be sent back for the function call x equal to Fibonacci of 2. So 2 recursive calls are made here. Now the execution of the program for input n equal to 5 is shown in detail here. You can go through the slides wherein it is clearly shown how exactly the recursive call is made. Go through it and execute the program and check the output.